Now we're talking about the traversal laws. So last time we wrote a few different functions. These were some exercises we did. We had some trouble with this final one, but I looked up the answer and then we sort of justified the answer. And the trick is like understanding that this is not sort of the real type signature. The real type signature is more like this, which helps you visualize sort of this left right handler SS thing, because it's really tough to visualize otherwise. You know, if you quickly look at this traversal with this type signature, it doesn't look like the type signature that you would expect, right? This takes 4 inputs, but if you just look at this, it doesn't look like 4 inputs. So anyway, once we sort of figured that out, then I think it became more clear. So we are on 7.6 Traversal Laws. And we'll see what happens. So get away with avoiding laws for folds, but traversals have a bit more structure, so we've got some laws to contend with. We need to respect purity. The first law is that running the traversal with an empty handler shouldn't change anything. It says that running the pure handler Okay, so let's do this one. So we're on y prime, so z prime of both pure don't touch. It's probably complaining because it doesn't understand what both is here. Pure could mean anything, so we need to give it the list mode, I guess. So this should be the list monad. Sorry, list monad. What the hell am I talking about? It should be the constructor that takes a string. Right. So this is list of string. Sure. Pure don't touch. Sure. That seems reasonable to me. So like you can do this with any applicative. Okay. So I think I did underscores next. If we did maybe okay, so the result of this should be don't touch, and the result of this one should be just don't touch. Okay, cool. So that's that. And now let's make a bad one. Bad tuple. Second traversal int a int b a b. Excuse me. Oh, I called it H. Yeah, that should be okay. All right, so again, this is sort of the trick, is you have to think of this like oh, it was trying to complete it for me actually. But it's, you have to think of this like A to B nope. I believe that's right. Oh, it's a, we need an F, right? So that's what you need to think of this type like. And so it can be a little bit tricky to get correct, or to think about anyway. I'm still not, whoops. Wait, why? There we go. I was wondering why that wouldn't work. It can be tricky to think about this sometimes, because that traversal is, you know, it's implying some structure that you kind of don't see, so it can be a little weird. Anyway, the point is that because this does this change in here, we're modifying the sort of underlying structure, and that's a problem. So this won't pass our laws. Now again, just to keep in mind that there are traversals that we've used already in this book that don't obey these laws, but that doesn't mean they're not useful. So, but this is a maybe an egregious one. Okay. So law 2, consistent focuses. This law looks a little crazy. Bonus points, you can work out what this is supposed to mean. Okay. All right, so let's start here. Yes. So traverse of my traverse G. Some traversal could be both, for example, I guess. And some function G. I guess this doesn't look that scary. I could see why the types would work, but what does it mean is a different question, right? That's a much trickier question as well. I don't necessarily know what it means. I mean, it looks like some sort of composition law, obviously. And this extra f map f is necessary because this thing is embedding some structure. So you need this extra, or I'm sorry, there's an extra structure on the outside of the result. So you're kind of doing like f dot g applied to whatever x is, I think. So if we thought about a specific instance of this, let's just try it, I guess. So if we do stack REPL, and what do we need to do? We need to import control lens. Then we could think like fmap traverse of both pure, and then traverse of both pure, and then we'll do it on this don't touch thing from before, because what I think is going to happen, if we say that this will be list of maybe string, I think what will happen is we just end up with that like this. Yeah, so it's kind of like it's a composition law but with extra structure. Yeah, and it looks more like that in this style, right? Because you have like this over, which is composing G with F, G after F, on each focus. Yeah, this seems easier to read for sure, but I sort of can see how this works, but not like what it means necessarily. It's some kind of composition law. Okay, we can check the law. We can express this law through an equality check by stating that running a traversal twice in a row with different handlers should be equivalent to running it once with the composition of those handlers. The law above includes the effects of the handler in its law, but for a simpler version, we can just consider the updates to the focused value itself by swapping in over instead of traverse up. So what the above law would simplify down if we chose identity as the effect. Okay. Sure. Law states that the traverse should never change which element it focuses, which elements it focuses, due to the alteration on those elements. Both is a law-abiding traversal, so we expect to see the equality hold for any structure or handlers we can dream up. Yeah, so I mean we kind of did this in this way, but we could change these functions to work on strings. So we could say like one of them is plus plus that, and another one can be take this. Well, it can just be yeah, I don't know. Put an A in front of it or something. We'll put a C in front of it, or chiroptical. But it doesn't really matter what we do, I think. Oh, but I can't do maybe. I need to do list of I think. Wouldn't that prepend a C? Oh, except I'm not adding any extra, right? Um, I need to embed structure, so like I have to do and I think the same thing here would have to be I need some kind of functor. Yeah, there we go. So I can't do that with just a normal A to B function. I need to embed additional structure. So here we could have written pure dot. I think we could just write pure dot this, and same thing here. Pure dot, and then again, I don't know why we're doing specifically this function, but the point is that you can see that this would work. That's all we're trying to prove. And we can write that in a slightly nicer way, apparently. Hey, Altern, what's going on? And also with this syntax, you get to write this, which is helpful. I think. Oh, except this doesn't work. I need this. There we go. Same thing. Obviously, this is much more verbose than this, but again, we're implementing some weird functions just to see if we can make it work. There you go. Okay. I think I said hi, but did I say how are you doing? I don't remember. So, how are you doing? Do anything interesting today? All right. There are various property-based testing libraries for QuickCheck and Hedgehog. Sure. Turns out that filtered is a law-breaking traversal. Yeah, I think that would make sense because we're wait, how does this work? 2 good. Oh, yeah, okay, I see how it works, right? We take 2, we add 1. That's what this is doing. And then why does this work in the first place? Don't we need some sort of functor to work with? Or are we working with num a? And what's the type of this, I guess? What am I doing? Integral. Yeah, so here. So basically we are on chapter 7. We've gone through sort of oh yeah. I think I read that without you even saying it, so it's interesting what your brain can like put in place. So we've learned what an optic is. We started with sort of the very basic lenses. Then we started to do the polymorphic optics. Then we started looking at the custom operators that are inside of um, the lens library and what they mean, because there's like a bunch of pretty weird syntax for sure. Then we started folds, which are just generic versions of traversals. So I think this is sort of the where things start to get very interesting with the traversals. So we've learned how to write our own custom traversals and these sorts of things. So it's been a wild journey. Been very fun. We're about a quarter of the way through the book, I guess. Well, a quarter would be 100, so a little further than that, but not quite a third. Or just past a third. I can do math, I swear. Yeah, so right now we're just learning about the laws that govern traversals. So if this was in a list, I guess I need to list of or something. So if I did this, this wouldn't work anymore. What is it? Set X flexible contexts. So I think we need what is it here? Folded. There we go. I was like, what is it? Yeah, so if it was in a list, we would need to traverse it. Then we could filter it. Anyway, that's an interesting one. But if we try to do this, then this won't do anything because we don't have any more even numbers. So we just get 3 back. But if you compose those together and then apply it on the focus, it's different. So that's kind of interesting. I don't know if hopefully that answers your question. Like if you have a more specific question, feel free to ask. That's kind of a generic question, so it's hard to answer in a precise way. All right, so good traversal, bad traversal. Why is there a traversal included in the lens library that blatantly breaks one of the laws? The traversal laws are more guidelines than anything. They help you to reason about behavior, but nothing is going to go horribly wrong if you break them. In fact, none of the combinators in the lens library actually rely on coherence to these laws. Some traversals, like filtered, are very useful, but can't be encoded in a legal way in Haskell, at least not without some advanced dependent types. I use law-breaking traversals all the time. Blah, blah, blah. Sure. All right. So basically, we learned about 2 laws. So sort of like an identity law, which is like traverse of I'll use the squiggly line to composition law, which is like we'll use this syntax. So it's like X my traversal at my F trav over G. I think that's the right word that composed at, yep, needs to be equivalent to X at my trav over G after F. Do I have this backwards? Yep. Okay. So exercises, traversal laws, worded is law breaking. I don't have a list of them, but you could look them up, for example. Here, I need to set up my other screen real quick. I think there's like even I think Chris actually made a cheat sheet. Optics cheat sheet. Yeah, so this. So there's a lot here. But yeah. Maybe that's helpful. Good. Maybe we need this open. Put it on Google for now. Okay, so which law does it break? And provide an example. All right, so I don't exactly remember what worded does, but we probably have an example here. All right, so worded okay. Hey, identity. Yep, I'm always streaming at this time, not always, obviously. You're streaming quite a bit more than me. Thank you. Yeah, I appreciate that. I should add you as well. That's a good idea. Because I like the Idris stuff that you're doing. Not that I can always follow it, but yeah, I'll do that. I'll do that later. Whoops. All right, so worded. So yeah, so like we could use it to set this whole thing. There's something to do with it's probably the composition law. So let's see, let's look at the identity law here. So given a worded. I don't see how it's going to break the identity law. So the question is, what combination of F and G cause worded to break? I can't see how worded would break the other one. So clearly we need like to write this out. So these are words. And we want to write at worded over something. F at worded over G. So what could F and G be to break this? I think is how I need to think that. What should I do? I'm thinking of it like filter, but like I don't want to use, I don't literally want to use filter in here. But if I just do something like I don't know. You don't have any ideas? I don't really have a good idea. What combination of F and G would fail here? Need to do something. I don't know. I've never been good at these types of questions, so I find these questions immensely hard as well. So we'll just write them out. But I think breaking the first law is easy. You just need to do something like this, where you have additional structure. You're done. So maybe I should be more clever than that, but like we can just make it a string and start adding dots to the end of it or something. But it's not going to be interesting at all. It's just going to be exactly like this. I think the one where it breaks the second law is a little trickier, but again, it could just be like a filter. So it doesn't need to be. It can just remove x's. I don't know, something like that. Okay, there we go. So So any traversal with a integer tagged attached can be law breaking. Doesn't have to be, but it can be, right? You know what? Let's do it. Let's just write an example with a string, and just to say we did something similar to bad tuple second. Let's not call it that because that's terrible. Let's call it b underscore, which is equally as terrible, but actually, well, we need b underscore here, so undefined c underscore can be a traversal string a, string b, ab. We're basically going to do the same thing, but we're just going to append. Actually, let's take a string. So log, and we'll just append the log. So kind of logging traversal. H what would you call this? Well, let's call this an entry, call this the log, and then some kind of a. And so if we tried to tuple up pure log entry with HA. That should type check, but it fails the first law. Suppose we can prove it if we needed to. I don't think we need to. I think it's kind of obvious that that's gonna fail. The second one can be a traversal I guess this should be fine. So we'll have a handler and some string, and then we'll just say does this pass? Okay, that is right. But filter something like this. Wait, what? Sorry. Duh. Filter character X. I don't know. Something like that would break the second law. But does it break the first law as well? I think it does. I don't know. That's not really the question. Just it breaks the second law. Maybe there'll be more interesting examples in the solutions that we can like think about. I don't know. Worded. know how to break this law. All right, so taking. I think that taking could fail. I don't know. I'm not a fan of these questions. Oh, I think I'm just gonna skip them. Like, if we really want to test them, maybe we can figure out, maybe what's more useful than doing these exercises is seeing if we can figure out how to test these with Quick Check or Hedgehog. Like, how do we, are there like traversal tests in Hedgehog or so Haskell test traversals? Tasty. Yeah, like it's more useful to like try and understand something like this than to tasty lens. Let's see if there's did we use Hedgehog before? I don't think so. Let's see if there's Quick Check lens. Lens properties. Quick check properties for lens. Here we go. So let's see if we can figure this out. So is traversal. Yep, this looks right. So let's try this. So if we want to do that, we need to, oops. We need to open up our spec. We need to look up an example of when I've done this before. I don't think it would make sense to sorry, Ken, I don't fully understand your question actually. I first read it and then I made an assumption of what I thought it was, but then I think I got confused. Would not have done that in the lens library. Would not have done what? Implement this lens properties thing? Yeah, so I think like again, there's I'm sure that they you know, they tested some of them, I would guess, but probably not all of them. I also don't see how you probably can't test the lens library if this thing depends on the lens library. Although maybe you can. I don't actually know. So let's see if we can do that. I don't know if we can, but where's an example where we've used Quick Check? So I don't have to like remember how to do the scaffolding. Probably in here somewhere. Okay, so let's just do this, I guess. Import quick check. We also need to edit our package YAML with test dependencies. That's executables. Tests, dependencies. I think it's just quick check. Do I need to write? Probably need to write just lens quick check like this, right? Lens, sorry, lens properties. That might be really useful actually, because oh, okay. So we need quick check. Is it actually capitalized? It probably is. It is. And then it might need lens as well, but we'll have to see. So stack test. And then let's bring this open. Here. Okay. We'll ignore this C preprocessor stuff. Okay, so I think that like we just want to check these properties, I guess. So we can just do that in a similar style to this one. Probably. Okay. We need a property, which is just going to be this is traversal thing, which comes from where? Control lens properties. Control lens properties. And then we can write prop worded, I guess. So is traversal guess it would be something like the following. Worded, which is a traversal of string, string, string. Import control lens. And then prop worded. And then for now, we'll just get rid of this because it's unnecessary. Expected type, actual type. How do I, what's underscore left, I guess? Is that in here? Do I need to do it this way? I don't think so. Maybe I do. Like, how do I know the type here for either? So I guess let's look at both. Oh wait, no. I know that, okay, it's probably just string to string. I'm stupid. Both requires a tuple, so it's gotta be that way. But this is probably like string would be fine. And then we can try and write a stack test down here. See if it works. Okay, so it failed pretty quick, so I guess that's good. But what failed? Very much unclear. And it doesn't really say what property failed either, so that's not particularly helpful. Maybe it would make more sense to separate our properties and not use is traversal directly, but use is traversal pure and is traversal compose or whatever. And then that way we can tell which one failed. But it's not clear to me. Well, we're never going to see the functions, are we? That's the problem. Because you can't really look at the functions. But it seems like something failed with an empty string. Or, well, a string with a space in it. But it's going to be hard to tell what went wrong. Let's go look at this is traversal code. And let's see what we can do here. All right, so what we want to do is pull this out. And then we want to, what is it, hiding? Import is that right? How do I ignore stuff? Ignore function from library Haskell. I feel like it's hiding. Ah, okay. So you write it afterwards. Totally fine. All right, and then we probably need some things to make this happy. Okay, we gotta go figure out what this is. I don't know what that is. Okay, so that's some sort of private function which we need to find. Traverse pure maybe. Ah, okay, so it's just specializing the type. And what's the other one we need? We need reverse, pure list, pure maybe, and compose, potentially. Maybe pure list, compose. And pure. Okay. So I just want to split these up. I hope this isn't too boring, but we'll see. Oh, we need to enable for all syntax, which is language existential quantification. Is that right? No. What's the right one? I don't remember. For all extension. Not explicit for all. Or does rank and types turn that on for us? And the error is something else. Unsure, but I don't think we need this. We do need compose, which I don't remember where that comes from offhand. Compose, data functor compose. Okay, so this is just an error, which is weird. Could not deduce applicative F1. What? Where is this thing? It's this one. This is what I want. I mean, seriously, Agelin? I don't want to do that. Okay, so that's that. This should all compile. Okay, so the next step is we want to pull out. We want to pull out the property AS is setter L traverse pure maybe L. Probably can just like remove all of this and see if it compiles. But actually, let's do the following. Is traversal ident and let's copy this. Do is traversal and those are silly suggestions as well. I think then we can just get rid of all this. I think this is everything to do with the two functions. And I think that this would describe the identity law. And then I think that we can get rid of oops, so it's like dot and dot. I think that that would be the composition law. Maybe? To be fair, I'm just guessing because I don't really know. Well, we can just look at what this does, I guess. What does pure list do? Just specializes this function. So you have some applicative and some eq instance. L pure. Oh, okay. I mean, this is the pure rule. So, if you do, okay, I see. So what we need to do is for is traversal pure, it's dot and dot. And then for this one, we just remove probably all of this. Can probably just be is setter L and then do, because that's the composition law. Apparently. Okay, so I think that's what we want. And then we want ident compose worded. And then this is going to be ident compose and then just for consistency's sake, we'll put this above stack test. So let's see if it even passes the identity law. It doesn't. So worded fails. Oh. It fails the identity law for an empty string because there's nothing to do. And also, it's kind of nice that it shows you this. Because I guess these are representations of function, like const A and const empty string. So I think that if we did at worded pure. Yeah, so there it is. So this returns empty list, but pure that returns a single space. So that makes sense. Okay, I understand that now. So that's actually helpful. So this is actually helpful, like, seriously. It's giving me a lot of like weird warnings, but that was useful to see which one it's actually failing. And also this is kind of interesting. So this means, I think, and this is also cool because I didn't know you could do this. I think this means if you take this and then you say worded const A wait, it's worded over const A at worded over const this is apparently different than A at worded over const A dot const. Is that right? FG wouldn't it be like this? I'm guessing that that's what this represents. So FG, G after F. Maybe that's not what this means. I don't know what this means necessarily. I just assumed it meant const A. If anyone has any suggestions, I'm open to them. This is also interesting. I don't know what this means. Like right hand side, left hand side, left hand side, left hand side, left hand side, right hand side, left hand side. I'm not really sure what that means in this context, but I'm also not like an expert here. So like it could be just doing something wrong or misinterpreting what this actually means. But I would guess this is F and this is G. Although maybe if you do this first, it's more complicated. So if we do it that way, what did I just do? I just did this. So that's G after F. The same. Path of traversals. I don't really know. Might mean that? Path. What do you mean by path, I guess? So if we look at this, what does a path mean? Because like we're thinking about pure maybe. I can only assume it means something related to this left hand side and this right hand side. I'm unsure. I guess we can go try and look. Yeah, it's just coming up with all kinds of weird stuff. Yeah, I don't really know. I would have also guessed that this means what I thought it means, but I don't think it does. Or I'm just writing out the law incorrectly. I don't know. But it does say it fails, so that's a thing. Yeah, so I guess this should be the composition law. So I don't know what this means. I don't actually know what this is. Like, this clearly is coming from prop worded, I guess. That's not how you comment things in this language. Let's see if it prints that out again, but I don't think it's going to. Oh, it does. Oh, maybe this means like, the only thing that's confusing is it said left-hand side, left-hand side. I don't know what that means. So I don't think that syntax meant anything that like I thought it did. But let's look at maybe this one. This is sort of interesting anyway. This is the last one I'm going to do, by the way. Yeah, like left-hand side, left-hand side. What does that mean? There's nothing here. But maybe that means empty? I don't think so. I think that space is always there. I don't know. Anyway, whatever. It was sort of an interesting little aside, but I don't think we really learned anything. I suppose we learned something. We don't need that. We don't need that. We need these though. Okay. So prop. Syntactic tree as a graph. That's true. I just don't. I don't know what that. I'm not gonna. I don't want to speculate on what that means. All right. So let's make sure that those things that we wrote before actually fail. So no lib tab. All right. So we wrote C underscore, and that should fail. Is traversal C underscore. Oh, I probably need to quantify it to, I don't know, string. It doesn't really matter. We can just put hello in front of there. And then this should have type traversal string. I think. Ah. Let's see if that works. Yep. Yeah, see, like this kind of does a similar thing though. Like I don't know what we're supposed to get here. Because I would expect to see hello somewhere in here for the purity law, but it's not there. So I don't know. It fails, I guess. And then the underscores. I think it'll be like that. Something like this. Yeah, see now we have two functions. So again, I don't really know what to think of all this stuff, but it does fail. What's really interesting is that it needs to encounter a test with an X to fail, but it always says A, and I think that's after the shrinking and stuff. I don't know if you can turn off the shrinking, which might help see the actual test that fails, but these ones are always really complicated, so anyway. But now we can just do the other ones. So prop taking taking beside. We're gonna have to define the types, so just give me a second. I want to see the failure before I move on. I don't even know what lined does. I assume lined is like worded. That seems problematic if traversed fails. Ooh, that's tough. So what's the type of taking? I think we need an integer. So we can just say okay. Expected type string f string actual type. What music goes with optics? Music that you would listen to from Sherlock Holmes. That would be my guess. How about the Pink Panther? Or the Inspector Gadget theme? Is this helpful? Let's just give it an integer. So maybe I don't know what those symbols are about. That almost looks like our rejects. I don't know. So let's look up a taking example. So taking 3 reversed. Random smiley from the list. I'm trying to figure out what way it goes. I don't know what the O's are at the bottom. Maybe I need an additional traversed. That's the whole lens. And then we can go for a list of string to list of string, something like that. So taking and traversal list of string, list of string. No. I have no idea what I'm looking at right now. What are those? Those are supposed to be smiley faces? So confused. Anyway. Twitch smile. Where do you get them? Anyway, how do I write this property for taking? Maybe there's an example in here. No taking example. Just type colon. Doesn't give me anything. Oh, and then you just start hitting tab? Is that what you're doing? There you go. On a Christmas tree by just holding tab. Certainly don't need this anymore, but let's put this back to Google. I don't know how to test this one. So like, yeah, maybe there's more stuff going on. So taking, maybe it's taking 10, not traversed, but taking 10 like this. Seems to still fail. What if I just do, instead of trying to like cheat, do traversing Hey Skybro, what's going on? Cojoined P well, we don't need applicative F. I don't know what P is. Maybe we need applicative F. Cojoined. Conjoined. Okay, and then we need to start specializing. So what we want is a list of string, string, I think. I don't think I'm gonna make this type check, by the way. I don't think I know how. Let's put all these in lists. See if that does anything. But like at this point I'm just guessing, so there's no way to figure this out from my standpoint. Because I don't know what it should be. Yeah. Okay, so I give up on trying to do this. The book just says decide whether you think it's lawful or not. If you think it's unlawful, come up with a counterexample of it being unlawful. So instead of trying to write these, maybe I should just give up. Do any of these work? Each should be able to do like int, I guess. Can't be int. It can? Yeah, I think I'm thinking about this incorrectly, so maybe that's the problem. So what, let me try one more time. Prop is traversal taking traversal prime string. No, it's got to be list of string, but no, it doesn't, because maybe I'm thinking about this incorrectly as well. This and if we do 10 or something. list of string. I don't know. That's enough for me. We can probably do each. Aligned should be fine with strings. Reverse. And also, can we do beside? That can't be right. Right? I don't think so. It's gonna take two traversals and create a traversal. Right? OSTAB. It's gotta be int, I think. And possibly this one as well. This one can be traversal prime. That one can be traversal prime. This one's gotta be something like this, right? I don't know. SSAA. So yeah, I think I had it. Like I would have guessed that it's gonna be like this. So the two structures are int and int, which means you stick the structures together. S and S prime, S and S, or T and T prime. But I'm missing this. Does that fix anything? No, it doesn't. So yeah, I don't know. I don't know how to test that one there. So we got these two. Can we do traverse? Just the question. Taking and beside. So beside. So what if we make it a list of integers? Sorry, I'm really stuck on this because I feel like it should be possible, and it's driving me a little nuts. So if we had a list of integer, we're going to focus on ints. So the structure would do something to those ints in the list. I don't think that that's actually illegal. So here we would need the structure focus structure nope. Okay, I'm done. Done. So A some kind of list should be fine, I guess. It's either gonna be like this or yeah. So quick check prop each. So lined will fail for the exact reasons that word fails. Each I'm unsure about. I'm not exactly sure how you would have each fail. So I think each is lawful. And I would guess as well traversed is lawful. So great, let's try it. I spent way too much time on that though. But that's fine. Lists are very problematic tests. Unfortunately, it's not clear to me. I think that we're going to have, yeah, let's just stop that. I think we're gonna blow up our RAM. So we need to do 30 tests, and also I would really like to have some print statements between these. So actually, we can probably change these strings to, well, lined really needs to be a string, but traverse could probably be integers, and that might help with that memory, but I don't see how we do lined. So let's just comment these out, and then we'll just do one at a time. Because I just want to see if this one works, basically. And I don't feel like putting print statements in there. I'll just run it 3 times. I don't care. Yeah, so this one's fine. I would guess that this one's going to fail very quickly for the same reasons that the other one fails. Although it may take a long time to generate a string. It doesn't. Okay. Anything with an empty is going to be an issue for lined. And this is probably the one that took a really long time, so we'll see if it gets to about 30 tests and stops. Okay, so it can just like get to a place where there's just an infinite list. What could we traverse? Let's traverse tuples. Let's do a traversal of tuples, and then I think that this would pass. The problem with lists is they're, too big. I think that it's generating really large lists and then doing some function along them that's computationally expensive with integers, I guess, and causing my computer to be very unhappy. So that's, if we do it with tuples, it should be a lot easier. And then putster len should fail. Lined should fail. That one should fail. That one should fail. And then just because it's easier to see, we'll do this one. Should pass. Okay. I wonder if there's a way to like control how big of lists can be made during quick check, because then we could actually test the list instance. Let's see if that's a thing. So quick check, control list length. Okay, so we could, well, we don't use this generator anywhere. We would have to we have to write this ourselves, I guess. But, it's not that important. Okay. There we go. So we're done with that. I think we need to keep moving because we're not getting anywhere. So let's go down here and say check test spec where we tried to use lens properties to check the rules, or the laws, which was kind of cool. 7.7, advanced manipulation. Alrighty. So, parts of is a higher order combinator which converts a traversal into a lens over a list of the traversal's focuses. Parts of, interesting. So the lens generated by parts of takes all the focuses of the provided traversal and packs them into a list for you to manipulate however you like. Is this similar to list of, but that version for, well, I guess we'll see how it behaves. Okay, so where are we? D, E. I want to write all of it. Okay, so this says traverse the list, focus on the first thing, and then gather those up in the list. How is this different than the following? Let's find out. So right. So what I did was focus on the character, but I can't manipulate. I can't manipulate the tuple if I'm focused on the character. I could only manipulate the character. Hence why identity worked. Hey, what's going on, for Hots and Pots? How are you? Yeah. So these are functionally equivalent, but it allows, I guess, an extra thing because you're sort of here. I'm collecting focuses by using the over by like a doing a manipulation, but here I'm not doing a manipulation. I'm viewing. So this is just the view operator. Just got up. Right. Yeah. Are you? Oh, you do the God, you had a name for it, but I don't remember what it is. But you sleep 3 times a day, right? Or you're awake? I don't remember how it works, but yeah, okay. So it wouldn't matter that you're like you're in Europe or something. It's not just late. Polyphasic. I'm not gonna remember that term, but maybe I will if you tell me every time. All right, so this kind of makes sense. Like the cool thing is you're using the view operator, and you're not doing any sort of manipulation. So that's kind of neat. You're not using a What is this one called? I mean, I just want to call it manipulation, but that feels wrong. So we'll see how it goes. Anyway, this makes sense to me, kind of. So it's like, yeah, it looks a lot like toList of. Yeah, this is a lens. Yeah, if you're not in a Sky, bro. I try to sleep at normal time, but I end up usually staying up later than I would like to. All right, yeah. So the difference, yeah. So here's the key, right? This is a traversal. This is a lens. That's actually kind of interesting. It still uses the traverse, so, but I guess it's just a lens. But that means we can edit the list and write results back. Well, that's weird. So we just do this, and then we can you maybe it's unhappy because it really wants to see a T. So A123 parts of traversed one set. What's the issue? F list car int set is applied to too few arguments. Oh, I'm missing an ampersand. So this is right. That is our operator, but what we want to do is use this operator. So I had the shape a little wrong. We probably don't even need a type there, but we can always get it. Well, okay, it defaults to an integer. That's right. Whoa, that's weird. Look at this one. How cool. I don't know how useful that is, but that's kind of neat. So actually, does this fail if I do cat? It doesn't. So that's good. It shouldn't fail, but I was kind of surprised to see that before. How weird. So we can do G. That's not how you spell leopard. Ay, ay, ay. All right, so that's kind of cool. Just keep in mind the rules. If the list has more elements than the traversal, the extras will be ignored. If the list has fewer elements than the traversal, unmatched portions of the traversal will be unaffected. It's because of these behaviors that parts of isn't a polymorphic lens. Fun function. Okay, sure. that seems fine. We're just applying reverse over to the collection of the things, which is, this is insane. Like, I don't know when you need this kind of stuff, but I guess when you need it, at least you have lenses. Sort, cool. Tail. Tail. How does this one work? Oh, right. The tail will be OF. So OF will replace the first two, and then F will remain at the end. That was kind of weird, but took me a second. All right. How is a raven like a writing desk? I've never heard that. Is that from something? Does anyone know? We could look it up, I suppose. All right, so each means over these. Traverse means, yeah, we might have to. I did talk about that at one point because we thought it might help, but that was before we started refactoring, and I think the refactored code is getting better. So like the way we were handling some of the stuff was more useful. Although there might be, like, the lens stuff might help with the way we have all the records and stuff. I don't know yet. Okay, so anyway, each traversed means, I think we're gonna focus on like the string, and I mean we can test it, right, by just doing view yep. Well, we can just let's just look it up now that we have the string together. I like lenses. I'm not sure that it will really add that much to the. I'm kind of afraid to click stuff. Unanswerable famous riddle. Alice Adventures in Wonderland. There you go. Lewis Carroll. Okay, so we focus on this. Unwords splits it into, you know, wait, unwords? Oh, duh. So words, I'm reading it the wrong way. Cool cat. So words gives us those, and then we sort that, and then we put them back, basically. Again, I don't know what this is necessary for, but you can do it. Oh, I get it. Okay. I read your "it will cool cat" differently, but I get it now. It will make it cooler. But then I have to explain lenses. So I should mention that at some point I would really like to explain that halogen example in like a blog post from beginning to end. Like, here's how you get started with halogen without having to read, hours of documentation. Something like that. Okay, so we can collect the characters into a list, then split them into words, sort them, then write back each individual character to a slot. Yeah, no, I think I'm okay with this. And then adding lenses would make that probably more intense. Yeah, no, I'm okay with this. This might be overly explained, but I'm not sure. Note that placement matters, just like Okay, parts of each like each tuple element into a list, then traverse that list. Sure, I think this makes sense. It's hard to, like, when you start reading these, you're sort of composing left to right versus right to left. Did I say that correctly? I think so. You can use parts of to edit elements using their neighbors as context. Here's a transformation which places each number with its percentage of the sum of all numbers in the structure. That's cool. Alright, so, right, we're focusing on the numbers, putting them into a list. We have that list, so we just divide each of them by their sum, and then put them back. That makes perfect sense. I mean, perfect sense is maybe not the right term, but I think I understand what's going on. Oh boy. You've seen how powerful parts of can be, but it can be a bit annoying when we can't change the type of the focus. There is, of course, a way around this. Unsafe parts of. Called unsafe for a reason. Okay, so we can change the type of things if we are careful. So if we say true, false, true, I guess this will work. Okay. Okay, so I'd recommend not using this with set, as it's pretty easy to get it wrong by accident. You can use it safely with over. Oh yeah, with over it would be fine. Because you don't have this issue of, like, setting. Okay, this example pairs each element with its successor if it exists. Okay, so focus on the characters. So we have A, B, C. Zip with comma. Just, oh, with its successor in the list. Sorry, I meant six, or I thought successor just meant like turn A into B, something like that. I was thinking of the succession function or something. So that's kind of cool though. That's weird. Unsafe parts of. Okay, cool. We've only scratched the surface of the real application parts of. Take some practice to understand when and where. Okay. Go ham wild. I don't know where this terminology comes from, but I certainly don't want to look it up. I discovered a very practical use case for parts of. They had a tree structure filled with user IDs, and they wanted to replace each ID with a full user object from their database. Okay. We have a user IDs, which is some tree of user ID. We have a lookup. Oh, I mean, yeah, obviously this is exactly what you want, because your function will just give you a list of user IDs for free. The parts of. So, and we need to flip the user from user ID to tree user, right? So there it is. Unsafe parts of traversed. That gives you a tree. What do we have? We have a tree of user ID. This is interesting. That's cool. Anyway, let's do some exercises. Okay, at least for my longer night sleep phase. I wish I was that like disciplined to do something like that. I just don't think I could do it. Fill in the blanks. So what does this return? We traverse, we filter even, and then we have the parts. So I think it's just 2, 4. That one doesn't look like a particularly useful. Yeah, I saw that actually. That was part of the motivation, or yeah, I mean that was part of the motivation for me wanting to do the books. Just how much Chris talks about lenses on, you know, Twitter and Slack and everything. He's very fond of lenses, and then also because Jappy was talking about it a ton. Is a bandicoot an actual like critter? I know of like Crash Bandicoot, and so I guess it's like an animal. So anyway, I know the other two. I've heard of an aardvark and capybara before, but never a bandicoot. I don't want to look it up, but I want to look it up on my phone first. Oh, it just looks like a little rat. Kind of cute, actually. Here, check this out. Bandicoot animal. They're like little rats. Marsupials or something. Kind of cute. Anyway. All right, so we're viewing, we're traversed, we're focusing on those, which I think will just give us a list. Then we parts of, which like makes all this the strings. Making 3 traverse. This one's kind of weird. I'm wondering, okay, what I think is going to happen is we're going to get AARBAN CAP, and we're going to replace as much of aardvark as we can. So I think that this is going to return 1, 2, 3 ban. What do you think? That's just a guess. This one feels weird to me. It doesn't do that. It's probably because it's taking 3 traversed. What happens if we remove the first traverse? Does it compile? It does compile. Does that do what I just thought might happen? No, that does nothing. Does literally nothing. Huh. Reversed. Taking 3. Do I need... What am I doing wrong? I'm kind of just putting stuff together. I feel myself drifting away from sanity. Well, really just awakeness. Maybe this has got to be like that. Yeah. It's got to be to list of, or it's not going to work. So that gathers up. This gathers up the elements of the list, puts them into, sorry, this puts them into a list. And then we take the first 3. Focus on these, stick those in a list. Okay. I think I'm okay now. Maybe. Oops. Okay, so I don't want to look at the type, but I clearly need both here, or sorry, beside. So it's going to be beside traverse traverse dot, is it traverse dot, sorry, not traversed, and then traversed 1, I think. And then another parenthesis. This work? Does that help? Oh, except it's K underscore. Okay. So this is not right. Oh, I think we just need one of these. And we need 2, not 1. No, we don't. I think it's just beside. Yeah. It's just traverse, right? Because this is just a map, so it automatically focuses on the right side. So we can probably even get rid of this now, and it should compile, I think. Yeah, so it's not. I suppose we could also do no, because we need to use different versions of traversed. So I think we do want beside. Interesting. Do we need this as well? Writing a lot of Python today. We do not. It can probably figure out that it can be just num a in that case. So L 2 I have a feeling it's going to be some kind of even. Something like this, I think. Yeah. So we collect up the evens and then set them to 2040. I suppose we could also write here. Actually, what I want to do is comment this and then say 10. Is this valid? Maybe not because of Zathura. I've never heard of Zathura. No instance for num. Huh. Okay. Whatever you say. I've never even heard of Zathura. Okay. I mean, it's got all the features I need. I don't know. I've been using events for a very long time, and I've never really had any issues with it. So that's usually the one I use. The only thing I can say that's a little annoying is, and if I thought it was that annoying, I could go try and fix it or submit a bug, is that when I open this and then close it, it refocuses and right. Actually, it didn't do it that time. Did it? I need to find more text. Yeah, so here we go. So I want to like center this, but if I click this and then, I don't know, it seems to work. I feel like it doesn't work all the time though. Anyway, M. So we just did that one, filtered even. Yeah, bugs fixed. XPDF. Yeah, I've not used that one. So something goes in here that sets the first one to kangaroo. I feel like there's head. So, oh, maybe it's traversed. Like that. I think it replaced the first character of each one of these, which is not what we wanted to do. Yeah, I mean, I don't have any issue. Like, I guess what's the issue with events? Like, why is that a problem? Because it requires GNOME, I guess, but I'm already using GNOME, so at least I think it requires GNOME. I just don't think that I mean, the search could be better, I guess. So if those two tools had better search functionality, maybe it would be useful. I don't know. And well, they're the same. Oh well, okay. I mean, Vim bindings everywhere is pretty useful. Yeah, yeah. I know what you meant. So maybe this is just parts of traversed. Oh, okay. It's not parts of traversed. Hmm. All right, so what are we doing here? Did I write traverse? No, I wrote traversed. How is it not traversed? Is it supposed to be double traversed? No, because traverse would focus on all the strings. So wouldn't it? I'm so confused. So if I just do that, makes a list of all my focuses. If I do that, would do that, which is what I want. That's the answer. Yeah, and it's easy because kangaroo is the right shape. Flex. DDG. I don't even know what DDG is. Okay. So there's M, N. Well, this is the answer to the previous question. But maybe the point is oh, DuckDuckGo. Okay. Sure. If I do this, what I actually get is Antvark, I think. Yeah. So I think it just to point out that, you know, what you just did above, dependent on the size, I think is the idea. N O map values are traversed in order by key. B, C, A. So I need a function that gives me B, then C, then A. I think. Because if I put reverse here, for example, I should get ABC, CBA. I think. ABC, CBA. But how do I get BCA from a function? I mean, I could just write a function that does what I want it to do, but it's not a pretty function. Oh, I see. The idea is that you're cycling through the keys. That's the idea. So if we do so you have XS and then we want to cycle, so it's going to be I mean, I want it to work for larger functions, so I'm just trying to see if there's a better way to write this. Like, what's the correct way to do this? So I think there's a cycle function. So what does cycle do exactly? I think it creates an infinite list. Oh, I have to wait for it to load because I don't have my local one or a local one. Oh, it's done loading, but we have not. Oh, there we go. Infinite list into a circular one. Yeah. So it's going to be take I think that's probably pretty generic, right? Like, take the tail of, you know, BC, or sorry, ABCA. I think that's right. Yeah. I don't hate that. What do you guys think? Any suggestions? Better suggestions? I'm not sure that there's a cleaner way to write that. But I'm open to suggestions. P. I think this is just parts of true. Yeah, I just like to think of, you know, other solutions sometimes. So, but yes, I agree. Generally speaking, that, you know, that's it just fine. Clearly, it's also more general than like specifically writing BCA thing, const BCA, because you could just write that. That would pass the test, right? Let me. Sorry. If we change this to const oop, right, that passes the test, but that's clearly not, you know, like that's not clearly not an elegant solution in any way. You know what I mean? Like, I don't even want to save this. Like, I want to make sure I delete this explicitly because it looks terrible. I think this is just parts of each. Oh. Bonus ones are always a little harder. Actually, this might be enough. I don't think I need that other traverse. Yeah. Like, I was thinking about this recently. I was talking to Chris about this. He was saying, like, you seem to be getting the hang of this stuff. And it's like, well, yeah, I'm really good at homework. You know what I mean? Like, this is basically like school, you know? I'm really good at this. But when it comes to doing this in practice, it's very different than doing this. And I don't, you know, sometimes I don't know how to make myself better at the sort of non-school problem. If that makes sense. I mean, this is just parts of. I'm pretty sure that's all you need. No, I guess not. Expected type, list of car. Actual type. I mean, yeah, that's the actual type. That's what it's supposed to be, isn't it? So parts of each. Uh, so parts of each is going to collect ABC, and then we take ABC and we fmap pre-tupling. I don't placing in first. What is this function called? Pre-tupling? I don't know, something like that. With itself. Or sorry, yeah. We tuple it up with um, the collected thing. What's wrong with this? I don't know. I don't know. Seems like it should be right to me. If we do this, view parts of each, we get ABC. And then we're going to modify each of them. Do we need a traverse in front of this? Or do we need an each in front of this? That can't be right. Panic! This can't be I mean, this can't legitimately be a bug. I want to close it. And I want to do stack build. I want to see if we can actually get the No, we can't get the bug out of there. But what's interesting is this is the same error as before. Oops. Did it actually not save? No, it did. Not exactly sure what's... Oh, we're changing the type. This is an unsafe. Oh, yeah, I mean, that's fine with me. What is this? I love tuple sections, they're my favorite. Right, so we have to be able to change the type there, otherwise we can't use, we just can't do this. So you need unsafe parts of there. You can't use parts of, because it wants to keep the list of car. Yeah. Now again, the unsafe is okay with over, or it's more okay with over. You don't want to use set here. So maybe I didn't show this before, but check this out. So if we do import control lens, and then we write this, but instead we write set a b, this will fail. Oh wait, no, this doesn't even type check. Oh, I used unsafe parts of. Wait, isn't this okay? Shouldn't this, like, runtime fail? List of B3. Oh, so maybe it just needs to be AB. Yeah. So if we do this, let me change this CD. So you'll see that what it's trying to do is use unsafe parts of and set the first two to C and D. But if you're using set with unsafe, these things need to be equal. So you can write CDE, that's totally valid. So you can see like set is a much more dangerous version, because you know these two things have to match your focus length. So the length of your focus for here has to be the same with a set. But with an over, if you're using a pure function like that, it's a little safer in that sense. But you know, it's unsafe. So I don't know when you justify the use of this necessarily, but I did at least recognize that I needed to use it, so that's good. Okay, cool. So that gets us to chapter 8. So let's quickly commit some